Alright, let's work on number 11. At this point, we're on 11. So we want to split this paper down the middle. Go to 5.5. Okay. Number 11. And number 11 says, solve the following system of equations graphically. And the two equations are, first we have y equals negative x plus 2, and then we have y equals x squared. That's it. So, the first one this time is obviously the line because nothing is squared. And the bottom one is a parabola because only one variable is squared. So as usual, we're going to start working with the parabola first. So what I do is I write down the general form for the equation of a parabola. And now I'm going to write down my equation underneath it and line up the terms. So I have all I have is an x squared term, so I'm going to put that underneath the x squared term. I have no x term, so I'll put plus 0x, and I have no term at the end, so I'll put plus 0. Okay? Now I can identify my a, b, and c. My a is 1, my b is 0, and my c is 0. Now I can identify my axis of symmetry. And we have x equals negative b over 2a, which equals negative 0 over 2 times 1, which is 0 over 2, which is 0. So our axis of symmetry is x equals 0. So let's set up our chart. In the middle of our chart, we have a 0. That's our axis of symmetry value. And let me just pull out a calculator. Let's plug in okay, we have clearing everything. I'm just putting in my x squared. So second table. And I want to do 3 values below 0, so negative 1, negative 2, negative 3, and 3 values above, so 1, 2, 3. So I'm going to go up to negative 3. My y is 9. At negative 2 it's 4. At negative 1, 1. 0, 0. 1, 1. 2, 4. 3, 9. Okay? So I'm just going to clean up my chart here. And I'm going to plot all these values, but first, and I'm going to draw my axis of symmetry, but first I'm going to work on my linear equation so we can all do it all at one time. So I'm going to bring my linear equation down here. It's y equals negative x plus 2. Now this is already in y equals mx plus b form. So my m you can see is negative 1 and my b is 2. So now let's draw our graph. This is 5.5. So we want to go to 2 3/4. Look, that looked like it was too far. Let me double check that. That's good. I'm drawing my y-axis right now. Okay. Now I'm going to go at 4 1/4, draw my x-axis. Okay. And I'm also going to label my quadrants first so I don't forget. 1, 2, 3, 4. And now I got to label my scale or my unit of increase here. I'm going by 1 in each direction, so I have to label that, at least that. Now, let's start with the axis of symmetry. Actually, well, it's right on x equals 0, which is the y-axis. So I'm just gonna label my y-axis, axis of symmetry, x equals 0. I'm not actually gonna draw a dashed line on top of that line. You don't have to do that. All right. So I'm going to plot my vertex first, 0, 0, and then I have 1, 1 and negative 1, 1. So 1, 1, negative 1, 1, 2, 4 and negative 2, 4, and 3, 9 and negative 3, 9. Okay. Label my graph, y equals x squared. Now draw my line. It's got a y-intercept of 2, and it's got a slope of negative 1. So remember, that's really over 1, so it's down 1 and to the right 1. Down to the right, down to the right, down to the right. I just make a couple of dots, and then I'm also going to go up and to the left. You can always go the opposite direction. And you can see the 2 points where it crosses. I'm going to label this y equals negative x plus 2. Circle the points of intersection, which are the solutions, and let's write them down. Negative 2, 4, which is in quadrant 2, and 1, 1 in quadrant 1. Okay? Before we check them, we're going to go and check them on our calculator first. So I'm putting in my line, negative x plus 2. I'm looking at my graph. It looks the same. I'm going to go to my table and see at negative 2 they both should be 4, which they are, and at 1 they should both be 1. Both y's should be 1 when x is 1, okay, which it is. So my calculator says it's right. Now let's go back to the graph and let's check the intersections. So second trace, intersect, go to the left point, enter, enter, enter. Negative 2, 4, so that's good. Let's do it again. Second trace, intersect, move the cursor to the second point, enter, enter, enter. 1, 1. So that's good. So it checks on the calculator. Now we have to show also our check algebraically. Okay, so let's check the first point, negative 2 comma 4, and we'll check it in y equals x squared. 4 equals negative 2 in parentheses squared, so 4 equals 4. That checks. Now let's check it in the linear equation. Y equals negative x plus 2. 4 equals negative 2 plus 2. 4 equals whoops, it's negative 2. Okay? So that would be 2 plus 2, so 4 equals 4. That checks. Let's check the other point, 1, 1. First in y equals x squared, 1 equals 1 squared, 1 equals 1. It checks. Now let's check the point 1, 1 in our linear equation. 1 equals negative 1 plus 2, 1 equals 1. That checks. So, everything checked out. Let's just clean it up. Okay, I actually didn't want that top line, but not a big deal. Okay, there it is. Alright, everything is clean, everything is complete. It's full credit for that problem. Let's go on the back and do number 12. Okay, here's my middle line. Solve the following system of equations graphically. Alright? And this time we have y equals x squared minus 4x, and we have x equals 4. Okay, so the top one is our parabola, the bottom one is our line. Okay, let's work with the parabola first. Let's write down the general form. Underneath that, let's put down, okay, that's all we have, right? And it's in order. The only thing we're missing is the c, so we just put plus 0 for that. So now, our a is 1, our b is negative 4, and our c is 0. Okay? So now write down x equal, actually, we have to identify what we're doing as our axis of symmetry. So axis of symmetry. X equals negative b over 2a, which is negative 4 over 2 times 1, which is 4 over 2, which is 2. So x equals 2 is our axis of symmetry. Let's do our table. 2 is in the middle of our table. Okay, we subtract 1 and again and again, and then we add 1 and then again and again. Let's see what we get when we plug this in for our y values. So we have x squared minus 4x. Go to our table and go to negative 1. I want that to be at the top. Okay. So I have 5, 0, negative 3, 0, negative 3, negative 4, negative 3, 0, 5. Clean this table up. Now, with x equals 4, we don't have to do anything because hopefully you know by this point that that is just going to be a vertical line that goes through 4 on the x-axis. Alright? So, let's graph this. It's on y-axis. Our x-axis, and we have to label our quadrants. 1, 2, 3, 4. And we have to identify the scale we're using, which is by ones. Okay? Now let's finish this. We have two negative, well, let's first do our axis of symmetry. It goes through 2, it's x equals 2, so that's this line right here. So I'm going to write right on top of it, axis of symmetry, x equals 2. First point, 2, negative 4. Then I have 1, negative 3, and 3, negative 3. Zero, 0, and 4, 0. Negative 1, 5, and 5, 5. Okay. Alright, so I'm going to write the equation on there. Y equals x squared minus 4x. Draw my line. My line is just a vertical line that goes through 4 on the x-axis. So we're only going to have one point of intersection here. So this is the line x equals 4. I labeled my line. Circle my point of intersection. Let's put down our answer, our solution, which is 4, 0 on the x-axis. Okay. That's it. Let's check it with our calculator, and then let's do our check by hand. So, x squared minus 4x. And the line x equals 4, we can't graph that one. Nope, we can't graph that line. So we can just look at our graph to make sure it looks similar. Okay. That's about all we can do with this one. Alright, and we know that x equals 4 is going to be a vertical line right here. Okay? So, now let's just do our check by hand. And we only have one point to check. 4, 0. So first I have y equals x squared minus 4x. So 0 equals 4 squared minus 4 times 4. 0 equals 16 minus 16, 0 equals 0. That checks. Now I have to check it in the line x equals 4. X is 4, so 4 equals 4. So that checks. Nice and quick and easy. Clean it up. Okay, so that is the end of that problem. All right, now we're going to take out a new sheet. And mark off my middle line. Draw a line down the middle. This is number 13. Solve the following system of equations graphically. And we have y equals, in parentheses, x plus 3 squared minus 4. And then we have y equals 2x plus 5. Okay. So first we have to do a little bit of manipulating to that top one, all right, because we have to get it into a form that we understand. So we're just going to work that problem out a little bit. So here's what I'm going to do. It's y equals, and that's x plus 3 squared, so that means x plus 3 times x plus 3, and then I have minus 4. Minus 4. Okay? So now I'm going to do a little more simplification. I'm going to do FOIL. Right? So I do my first terms, x times x, that's x squared. Then I do my outer terms, x times 3, so that's plus 3x. I do my inner terms, that's another plus 3x. And I do my last terms, 3 times 3 is 9, so that's plus 9, and I still have that minus 4. Now I'm just going to clean it up by combining like terms. So y equals, my x squared is still by itself. 3x and 3x becomes a 6x. And then positive 9 minus 4 is a positive 5. So now we can see that this is a parabola. So the bottom one is also a line because it doesn't have anything squared. Now we're in standard form, right? We're in our y equals ax squared plus bx plus c form. So let's just identify our a is 1, our b is 6, and our c is 5. So now let's find the axis of symmetry. X equals negative b over 2a, which is negative 6 over 2 times 1. So that's negative 6 over 2, so negative 3. X equals negative 3 is our axis of symmetry. We're going to do our table, and our middle value is negative 3. And then we're going to go down by 1, down by 1, down by 1, and up by 1, up by 1, up by 1. So I'm going to put this equation in exactly as it is, x plus 3 squared minus 4. Okay, and at negative 6 we have 5, at negative 5, 0, at negative 4 it's negative 3, negative 3 is negative 4, and now we should go right back up. At negative 2 is negative 3, at negative 1 is 0, and at 0 it's 5. Okay, so we're done with the parabola part. Now let's just identify our slope and y-intercept, because this is already in y equals mx plus b form, so they were nice to us with the linear equation, but they weren't that nice with the parabola. They made us do some switching around. Okay? So so there's where my y-axis is going to go. And that's where my x-axis is going to go. Let's label our quadrants. 1, 2, 3, 4, and let's label our scale. Alright, I'm going to start with the parabola again. I'm going to start with my middle value, negative 3, negative 4. Let me draw my axis of symmetry before I go any further. It's at x equals negative 3. Which of course is going to go right through the middle value of my table, and this turning point of the parabola is called the vertex. So now I'm going to plot negative 4, negative 3, and negative 2, negative 3. Then I'm going to plot negative 5, 0, and negative 1, 0. And then negative 6, 5, and 0, 5. Okay. I'm going to label this y equals x plus 3 squared minus 4. I always label with the original equation. Now my y-intercept is 1, 2, 3, 4, 5, so that's going to be 1 point of intersection, and my slope is 2. That means up 2 and over 1, right? So up 2 over 1, up 2 over 1. Then we can also go down 2 to the left, down 2 to the left 1, down 2 to the left 1, down 2 to the left 1. So there's my other point of intersection, down 2 and to the left 1. So this time I have 2 solutions. Y equals 2x plus 5. Okay, so my first solution is negative 1, negative 2, negative 3, negative 4, negative 3. and that's in quadrant 3. And my other solution is 0, 5, and that's in quadrant 1. So let's just check this out on our calculator. We already have the quadratic, so now let's put in the 2x plus 5, the linear. Let's go to our graph. Okay, you can see it looks the same. Let's go to our table. Now at an x value of -4, both y's should be -3, which they are. And at the x value of 0, both y's should be 5, which they are. Now let's also check the intersection, second trace. Intersect, first put it next to the left point. Hit enter, enter, enter. -4, -3, that's one answer. Second trace, intersect. Go back to the right point. Enter, enter, enter. 0, 5. Okay, so we checked it with our graphing calculator. Now let's also show our check by hand. -4, -3, and we're going to check that first. In y equals x plus 3 squared minus 4. So -3 equals -4 plus 3 squared minus 4. -3 equals -1 squared minus 4. -3 equals 1 minus 4. -3 equals -3. That checks. Okay. I'm going to check the same the same point underneath this in the next equation, because I think I don't want to run out of room. So it's y equals 2x plus 5. So -3 equals 2 times -4 plus 5. So -3 equals 2 times -4 is -8. -8 plus 5 is -3. So it checks. Next point is 0, 5. And first I'm going to check that in y equals x plus 3 squared minus 4. 5 equals 0 plus 3 squared minus 4. 5 equals 3 squared minus 4. 5 equals 9 minus 4. 5 equals 5. Now let's check it in y equals 2x plus 5. 5 equals 2 times 0 plus 5. 5 equals 2 times 0 is 0. 0 plus 5 is 5. So it checks in both. Let's just clean it up a little bit. Okay, there it is. All right. So, next problem is number 14. Solve the following system of equations graphically. And we have y equals, in parentheses, x minus 2 squared plus 4. And then we have 4x plus 2y equals 14.